In this lesson, we will learn about energizing of RL circuit. RL circuit consists of a resistor and an inductor. Let's look at the inductor first. Inductor is made of an electric coil, a coil of a conductor, conducting coil. When current changes, current across the coil changes, okay, for example, current is increasing in this direction, magnetic field will be generated, okay, and the magnetic field will induce an electric potential such that the potential opposes the change of the current. Okay, in this case, if the current is increasing in this direction, the potential will be like this so that it opposes the current. Now let's look at the circuit. Initially here the switch is off, therefore the current is 0. When we turn on the switch, the current will try to flow in this direction, and because it's trying to flow in this direction, the potential over here will be induced such that it's positive here and negative here, and it can oppose the current. Okay, so the initial voltage here, the moment we turn on the switch, the initial voltage at this point will be same as this, okay, which is like in this case 10 volt. And when both values are same, we don't have potential difference between these 2 points. It's 10 here and 10 here. Therefore, the current initially is 0. Okay, and as time passes, this voltage will drop. It will drop to 0. Okay, 10, 9, 7, 8, and so on to 0. And as this voltage drops, you can see the potential difference between this point and this point will increase. Okay, for example, if it is 7, it's 10 here, 7 here. So there's a voltage difference of 3 volt. Okay, so as it's decreasing, the difference is increasing. Hence, the current will increase. Okay, current is the potential difference divided by the resistor, Ohm's law. So that is what is being shown in these two plots. Here it shows how the voltage across the inductor, initially the initial voltage is same as the source voltage, and as time passes, this voltage decreases to 0. Current on the other hand is initially 0 because 10 and 10 no difference, okay, and eventually it becomes the maximum current. Okay, here the voltage is already 0, so the difference is same as the E. Okay, the voltage difference between this point and this point is in this case E or 10 volt, and then using Ohm's law we know current is E over the resistor. Okay, so we get this is the maximum current. If you want to find the voltage or current at any other time, for example, you want to know what is the voltage here, then you can just use this equation. Okay, this shows the voltage, this is the time, resistor, inductor, and this is the source voltage. Okay, it's all given here. I have also rearranged the equation in case you want to find the time L or R, you can use this equation. Similarly, this is for the current across the inductor. Okay, the current across the inductor you can find at any time using this equation. Just substitute the value of the t. Okay, one more thing worth noting is we can see initially when we just turn on the switch, the inductor is acting like an open circuit. Okay, the inductor is like an open circuit because it doesn't allow current to flow. Current is 0. But at steady state, the inductor becomes a short circuit. Okay, this is when time equals to 0, it's open circuit. When time goes to infinity, steady state, it's a short circuit. It's just like a wire, and therefore the current is just E over R. That's all. Thank you.